and I'll be moderating today's Pulmonary Critical Care and Sleep Medicine Grand Rounds. This is a special Grand Round as it marks the 10th annual Sreedhar Nair Endowed Lecture. Dr. Nair was a major national and international leader in pulmonary medicine. He came to the United States from India and trained in pulmonary medicine in New York City. He was one of the first physicians to take and pass the ABIM examination in pulmonary medicine. Sri, as he was affectionately known by many of his friends and colleagues, practiced at Norwalk Hospital in Connecticut, where he was chief of pulmonary and critical care medicine for many years. In the mid-1970s, Dr. Nair established the National Emphysema Foundation, funded largely by his many grateful patients. For more than 4 decades, his foundation has funded research projects in Connecticut and throughout the United States, and has been a major source of lecture support at national academic centers, including Yale. The American Thoracic Society awarded Dr. Nair the International Health Award for his contributions to pulmonary medicine in India and other countries. With his wide vision and wisdom, Sri was a supporter of telemedicine years before it became important in the United States and throughout the world. After Sri's death in March 2014, his family and the National Emphysema Foundation endowed an annual lecture in his honor at Yale. We are very pleased to have Dr. Crotty as our 10th annual Sreedhar Nair visiting professor and PCCSM Grand Round speaker. Dr. Crotty is an associate professor of medicine in residence at the University of California at San Diego in the Division of Pulmonary and Critical Care Medicine, and section chief of Pulmonary and Critical Care Medicine at the Veterans Affairs San Diego Health System. She completed her undergraduate and medical degrees at Duke University, followed by internal medicine residency, chief residency, and pulmonary critical care fellowship at Mass General Hospital. She's a highly accomplished and internationally recognized physician scientist with focus and expertise on the health effects of electronic cigarettes. Her lab also studies the impacts of inhalants on bacterial pathogenesis, molecular pathways in asthma pathogenesis, and the role of neutrophils in acute lung injury. Dr. Crotty is extensively funded by the National Heart, Lung, and Blood Institute of the National Institutes of Health, the VA San Diego Healthcare System, and by the state of California. She has over 80 peer-reviewed publications in esteemed journals, including Nature, Nature Communications, the American Journal of Respiratory and Critical Care Medicine, the American Journal of Respiratory Cellular and Molecular Biology, and many others. Her talk today is titled The Broad Impact of E-Cigarette Vaping on Health. Dr. Crotty, thank you for being here with us today.
Thank you. Thank you for that overly kind introduction. Much appreciated. And I would like to be even more extensively funded in the next few years. I'm sure everybody here will feel that way. And my only other disclosure is I served once on the Regeneron Advisory Board for COPD. And here is the disclosure and accreditation. Do I need to leave it up there for no? Okay. All right, so I could talk forever about e-cigarettes. We're going to take a journey today. We're going to take you through lots of different things that I've learned and found along the way. Please do ask questions as we go. But I was thinking about it, and if you could walk away with 5 things that I want you to know about e-cigarettes, these would be them. So e-cigarettes do cause lung disease through inflammation and lung injury. Which ones and how much we're still working on. They will cause cancer. I'm going to show you some of the data from our lab and other labs to support that. They affect organ systems across the body. So if you think about cigarette smokers, they're affected across the body by the chemicals they inhale. The same thing is happening with e-cigarettes. Dual use of combustible tobacco with e-cigarettes is way worse than either one alone. So this is research that is really cutting edge and it's really coming out across multiple different labs, but basically don't use them together. And finally, if you have a patient and you ask them if they smoke or they vape and they say yes to one or the other, odds are that they're doing another inhalant as well. Okay, so tobacco, where we all started. So tobacco is still a major problem. I spent 10 years in Durham. And so I remember in the fall, we would smell the sweetness of the drying tobacco leaves like every year. So drying tobacco smells a lot better than burning tobacco. Worldwide, we still have 8 million deaths due to tobacco and 480,000 here in the US. But right now, like, we make huge strides on kids getting away from combustible tobacco, but unfortunately, they really switched to e-cigarettes. So this is the data from a couple years ago. So 16% of high school students had used a tobacco product, and basically 14%, was e-cigarettes. So the big aqua column, and then you see all the other sort of types like smokeless tobacco, cigarettes, cigars along the bottom. So they're very appealing to youth. In the upper left-hand corner is the original e-cigarette from way back when, 2007, when they first came on the international market and were designed to look like regular cigarettes. And I put that one up there because even though all these other ones that are more modern can look very, very different, they all have the same components. They all have a tank or cartridge that holds the e-liquid, and then they have an atomizer, which is activated by a battery to heat up the liquid and then pull it through a mesh to become an aerosol. Now, the old ones used to only hold a small amount of e-liquid, and they had lower levels of nicotine. But then in the era of Juul, 2016, 2017, the fourth generation devices rose, and that's all of them now are fourth gen pod devices that hold nicotinic salts at a concentration of 59 milligrams per mil. So for a Juul, the pod holds 600 microliters of e-liquid, and that has the equivalent nicotine as 1 pack of cigarettes. But these larger ones on the right-hand side, those hold 12 milliliters of e-liquid, so the equivalent of 20 to 30 packs of cigarettes worth of nicotine in the one device. I also like talking about e-cigarettes because it's really fun to see all the sneaky ways that they convert these devices. So I particularly like the inhalers. It's just kind of horrifying, but then the Sharpie I thought was also a fascinating choice. And then I was browsing Amazon just to see what kind of e-cig stuff they have, because this is what e-cigarette researchers do. And if your patients are having difficulty tracking which flavors they prefer, there is a flavor tracker for sale. So what else is in there? So the e-liquids are mainly propylene glycol, glycerin, and nicotinic salts. But in the green, you'll see that as the battery heats the coil, a lot of the metals and even plastics that are around it get leached into the chemicals and go into the aerosols. Now, we're about the e-liquids contain 30 to 60 chemicals. Because they get heated and mixed with water and oxygen, the aerosol itself usually holds about 100 to 150 different chemicals. So the CDC has a really nice website. So if you ever need like a primer, or you have a patient who wants to know, or a parent, they have a great set of information about e-cigarettes. So 2007, they entered the US. 2009, the FDA actually did try to block them coming in, but because they felt like this was a nicotine delivery device, and so it should be regulated as a medical device. Companies sued, and a federal judge ruled in their favor, so that they are not regulated by the FDA. So we lost that one. So by 2018, the whole country had really realized that this was an epidemic. So at that time, the number of 18 to 29-year-olds that had used an e-cigarette was at 85%. So pretty high. But if you see, like, our older populations are not as interested in e-cigarettes, and this pattern sort of holds true still. They're very much popular still with the youth. We're really happy in 2019, the federal law raised the minimum legal sales to 21. Connecticut followed this rule, and more than half of the states have implemented it. And then in 2020, they did try and curb the epidemic by trying to ban the sale of flavored pods. The companies are so fast at switching that within a year they had switched to disposables, and the disposables rose in popularity. So by 2021, 53% of the youth had switched. So this environmentally is really bad, because that means that every time somebody buys a vape and throws out a vape, they're throwing out a lithium-ion battery, plastics, metals into the landfill. So technically, it would have been better to stick with the pods that you could refill for the environment. So 2022, the e-cig epidemic had continued, but we actually had seen it fall from 2019. So So during the pandemic, the rates by adolescents did fall, and they haven't really picked back up to that peak. But that being said, we still have more than 3 million middle and high school students using. So what's going on in Connecticut? Well, you guys are actually doing really well on the tobacco scene. So in 2021, 11% of your high school students vaped versus 18% nationwide. And in 2022, 6% of your adults vaped versus 8% nationally, and 10% smoked versus 14% nationally. So I was very impressed with Connecticut. Go Connecticut. You're also ranked 3rd for the highest tobacco taxes in the country, which is also great. So the big thing that has changed in the field in the last few years is the realization that most people who are vaping are dual using or triple using with other products. So dual use with combustible tobacco or dual use with cannabis, which is legal here in Connecticut. And while you guys are doing great on the tobacco front, your rates of cannabis use are higher, actually. 21% in Connecticut in adults versus 18% nationwide, and 45% of your young adults have used in the last 30 days. When we started looking at our teenagers across the country, we realized that they were really following these patterns too. So in the columns are the percentage of each of the user types underneath that are also using marijuana. So you'll see our conventional tobacco users in that second column, they're about 18% of them co-use with a form of cannabis. Whereas our e-cig vapors, about 45% of them co-use with cannabis. And then our triple users are vapors who also smoke and use cannabis. And so those are also 40%. So these are like really big parts of the population of e-cigarette vapors now. And this is true across multiple studies. So this wasn't our just little study, but Ajit did this review of 4 big articles. And if you look in the graph, you'll see that they all detected very similar levels of triple use and dual use, and that both of those were at higher amounts of just sole cigarette use or sole e-cigarette use. One of the women in my lab, Annie, she wondered why in the world an adolescent who is vaping like bubblegum e-cigarettes would switch to combustible tobacco or add in combustible tobacco. And I was like, I really don't know. Is it the price? Is it they need more nicotine? Is it easier to get? And so we designed this survey that she ran, and these are her results that she presented at ATS. And I think the hardest thing about this data is that in the top column, these are vapors who switched to smoking. And you'll see that the top reason was that smoking cigarettes is healthier than vaping nicotine. But then if you look at the bottom one, those are the people who were smokers and they switched to vaping. And you see the second reason is vaping nicotine is healthier than smoking cigarettes. So basically it just means that, you know, we have mixed messaging going out to everybody. And so in terms of like which one is more dangerous, like people don't clearly seem to know. And so they're using that as a reason to switch. In terms of why somebody would dual use, there wasn't really a dominant reason. People reported using both combustible tobacco and e-cigarettes to increase enjoyment, have more variety, or just because other people are using those devices around them. Okay, so that's like a little bit of our background. We're going to circle back to a couple other points, but I wanted to share some e-cigarette mouse work that we've been working on. And so this is a bulk RNA-seq from mouse lungs, where we exposed them to 4 different flavors. So along the bottom, you'll see that they were exposed to tobacco. These are jewels, actually. Tobacco jewel, menthol jewel, mango jewel, and mint jewel, which are actually no longer on the market. And what we see here is that the flavors themselves can have a dramatic impact. So these are just some of the inflammatory and immune pathways that were most affected by daily inhalation of these tobacco aerosols. And you'll see that the tobacco and menthol kind of grouped together. And when we look, there wasn't really a common chemical flavorant that was in there. So it's a little unclear what is the driver or whether that's actually the nicotine impact. Whereas on the mango and mint, they did have a couple of chemical flavorants in common. And you'll see that the tobacco and menthol really had a suppressive effect across these immune and inflammatory pathways, versus mango and mint had more of a pro-inflammatory effect. And we're sort of wrangling our way through some of the more specific pathways. But what you'll really notice is the first few columns are air controls, and then tobacco menthol, and then mango mint on the far right. And if you look across these six, you'll see this sort of patch of blue where the menthol and the tobacco are. And of course, I'm a little bit more interested in the toll-like receptor signaling and the macrophage signaling, just as evidence of suppression of innate immunology in the lungs. Another thing that we've looked at is sex differences. So now not only do we know that the flavors are causing very specific changes in the lung gene expression, but also depends on whether you're exposing female mice or male mice to these same inhalants. So whereas the females had a pro-inflammatory sort of reaction to the inhalant, the males had the opposite. And so again, it just tells us we do need to be studying both sexes. And these are some of our CD1 mice in our exposure chamber there. In terms of other sex differences that we've looked at, we ran metabolomics on plasma from these mice, and there was only one chemical in common between the males and the females. Again, just suggesting that they're having different responses. So I like this sort of framework because it reminds me of all the different things in the e-cigarettes that might be impacting what we're seeing physiologically and immunologically. So the e-device generation, so we have first through fourth generation devices, so the Cigalites, the vape pens, the box mods, and the pod-based devices. And when we've studied each one of these in mice, we've sort of seen different things in the mice. Flavors, I just showed you 4 different flavors, and they sort of segregated into 2 different patterns. Nicotine concentration, so I think I mentioned the first 3 generations were actually pretty low concentration of nicotine, usually 1 to 6 milligrams per mil was most common, whereas now they use the 59 milligrams per mil, so very high concentrations, and so we're seeing different patterns. Use with other inhalants, I'm going to share with you some of that data. And then patterns of use and wattage, we know change the chemical exposures as well. Okay, so back to our humans. As a mother of teenagers / pre-teenagers, I'm like really worried about initiation. So I go around and I talk at middle schools, elementary schools, even colleges about e-cigarettes just to share information. So hopefully they'll make good choices. My 14-year-old said that, Mom, I'm never going to vape. And I'm like, here, can you write that down and sign it in blood? Because 2 of my e-cigarette research colleagues have daughters who are teenagers, and they're both vaping now. And so they're like, what do I do? Choices. But the reason that we worry about initiation of e-cigarettes is because it increases your odds of adding in or switching to combustible tobacco, which we know all the horrible things about combustible tobacco. So really when I go out and talk, I say it increases your odds of starting to be a combustible smoker by 4 times. Good news is that in 2023, Juul lost many settlements, so lots of money is coming to different states because they were directly targeting young people with their advertisements. So Connecticut is getting 16 million of the settlement, woohoo! And they're going to use that towards cessation, prevention, and mitigation. So speaking of cessation, can e-cigarettes be used for cessation? Are they useful in that way? Any votes? So the first 3 generations were epic failures, and that probably is because of the low concentration of nicotine that they had in them. It just wasn't enough to compete with the high of a combustible tobacco cigarette. But the Juul 4th gen 59 milligrams per mil can easily get that same high as smoking combustible tobacco. And some teenagers have called it the same as like chugging a beer, like just taking a hit off of the Juul or chugging a beer. And I'm like, why are you doing either of those things? So the newer studies have really suggested that you can switch with the e-cigarette, that there are smokers out there who successfully switch, but it's not cessation, it's just switching. So they switch from one form of tobacco to another. But the concept of harm reduction has always been there in the e-cigarette field, and the FDA actually just released this a month ago. was really upsetting for some hardcore anti-e-cigarette folks because they basically said that switching completely from cigarettes to e-cigarettes in purple may reduce exposure to many harmful chemicals, which is true. However, it's important that they switch completely from cigarettes to e-cigarettes to get the full health benefit. And so we're going to talk a little bit about that because the problem is a lot of people use the e-cigarettes to cut back on combustibles, but they don't fully quit. And so then they are using both. And back to the number of deaths per year. So if e-cigarettes are 80% safer, which we don't know yet, but you would still have 1.6 million deaths per year worldwide. So we talked a little bit about mouse data, talked about initiation, but what diseases do we think are going to show up in our e-cigarette patients who have been vaping for 10, 20 years? One interesting pattern that we noticed was actually our dual users of THC and nicotine, so these are teenagers, they actually have a higher intake of sugary drinks and sweets, even though their exercise levels are the same. This was a study designed by a teenager who wanted to know if vaping THC caused the munchies the same amount that combustible THC did. That didn't pan out, but we did find this, that those dual users in the dark blue have these higher intake of sweets, which is suggested that they might develop metabolic syndrome. This is a review article, so if you want to go hardcore in depth about all the different things that happen in the lungs, this covers it very nicely in terms of the lung itself, physiology, host defense. And then we also included aspects across the body. So addiction disorders, gum disease, accumulation of fat in the liver. So the only known disease that is specific for e-cigarettes is the e-cigarette or vaping product use associated lung injury, E-valley disease that was recognized in 2019. So that remains the only one that is specific for e-cigarettes, even though e-cigarettes have been reported to cause pretty much every lung disease out there. So you can find case reports for all of them in the literature. But for E-valley, at the time, the 2019 epidemic, it was in mainly THC vapors. So 82% were sole users of THC vapes. So 16 to 18% of those who got diagnosed with E-valley vape nicotine alone. However, the landscape has changed a lot. So now, in the last couple of years, the people showing up with E-valley, 50% of them are THC vapors and 50% vape nicotine. And I only bring this up because the original epidemic was found to be caused by vitamin E acetate being added to the THC vapes. And it just turns out that vitamin E acetate directly or through chemical reactions that happen during vaping is like highly toxic to the lungs and causes ARDS. So since then, people have been looking at the BAL of the new E-valleys, looking for this drug and this chemical, and it is being found. But again, half of these people are nicotine vapors, so it's not just our THC vapors affected by this disease. At the time, I mentioned this to someone else, it was really fun to be an e-cigarette expert because JCI came to me and they're like, what do you think is happening with E-valley? Can you write a piece? And I'm like, you mean not based on any data, just write what I think is happening? And they're like, yes. And I'm like, sure. So I just wrote what I thought was happening and they published it. So it was great. But this is one of the diagrams that we made for it. And I think this still holds true as to what I think is going on. So on the left-hand side is a regular lung, but they've been vaping. And so when we look histopathologically, we don't see many changes. So we don't see a ton of immune cells or fibrosis or anything in the lungs of our mice. But we know that those cells are being modulated by the exposure. So that bulk RNA-seq and some more focused flow cytometry has taught us that. And so we hypothesized with a second hit, such as like air pollution, a virus, a bacterial infection, that you're going to have a different response than you would have if you hadn't have vaped. And so in this case, leading to acute lung injury as one of the pathways. So I get asked this a lot. You already know my opinion on this, and I'm going to explain to you why. So one thing is that e-cigarettes damage DNA. So this is actually the first article that I published in the field was actually on e-cigarettes causing double-stranded DNA breaks. And then there's been several studies published since then showing different other forms of DNA damage or decreased DNA repair. So they cause DNA damage. They also cause inflammation. So we've actually seen a huge inflammatory signal in the GI tract. So not so much in the lungs, but in the GI tract, we're seeing massive accumulation of immune cells. So in this 3-month mouse exposure, on the left are our air controls, and they have beautiful colonic epithelium. But then our e-cigarette without nicotine, our vehicle controls, they have these huge patches of inflammation, which is sort of moderate in our e-cig with nicotine, but still more so than our controls. So if you think about it, and all these different drivers that come together to cause cancer, we already have the blue and yellow proven, and some of these specific things have also been proven. But on the right, we're still working on this side. So on the red, the epithelial barrier breakdown, when we've done exposures at air-liquid interface with human cells, it definitely causes breakdown of the zonas occludens, and so there's more leakage. So we think that's playing a factor. But what we really want to dig into is the immunomodulation to see if the cells that usually would defend you against cancer might be altered. I already showed you some of our mouse data, but this is our setup. One of our master's students actually built this with his dad one weekend so that we could do more exposures at the same time. So we have the sash up right now, but we can expose 5 different sets of mice at the same time. And so what we did after this is we did the histologic scoring on our mice. We also exposed mice to cigarette smoke so that we could see a side-by-side comparison. And we did a dual exposure. So in this one on the far left is our air, and then our e-cig with nicotine, cigarette smoke, and then e-cig with cigarette smoke. And that would be our purple one. And when we graded them, you saw more and more inflammation as you go across those exposures. The other thing that we saw were increased markers of proliferation, which again, were present in the e-cigs in red, but were higher in, well, trended higher in the dual use in purple. So then we decided to expose our APC knockout mice. So that's a model of familial adenomatous polyposis. And we exposed them for about 6 to 8 weeks. And top one is the air control. So they develop adenomas naturally because of this gene change. And our e-cigarette exposed and B, they have more adenomas, and they have about the same in the cigarette smoke, and they have more in the dual exposure. So why is that dual exposure really driving things? So we started looking at the double-stranded DNA breaks, and so we've documented that that is worse in our DNA, in our dual exposures, decreased DNA repair as well. And then in this table is just like a set of some of the downregulated pathways on the left, and you'll see a lot of them being these DNA repair pathways. So that's the colon. So we all worry about colon cancer, but we also are lung doctors, so worry about lung cancer as well. So we also use the KRAS mouse model, and so these mice develop lung adenomas spontaneously. And so we put them through the same exposure, and we found that the e-cigarette with nicotine and the vehicle control both had higher numbers of adenomas. And when we've done the volume assessments, that's held true as well. This isn't, that surprising because this paper came out in 2019, Tang et al., and they exposed their mice for 53 weeks. I think it was at least 4 hours a day, so it was super intense exposure. And you'll see that the e-cigarette with nicotine group had a 22% lung cancer incidence versus 5%, 6% of the air controls and none of the vehicles. So there have been signals coming through from multiple groups about the pro-tumorigenesis part. This is the brand new data that there's actually been headlines just last week. It was actually presented just a couple months ago at the AACR in San Diego, actually. And she did a retrospective cohort study and found that people who were dual vapors and smokers had an odds ratio of 21 to develop lung cancer versus an odds ratio of 6 if you were a combustible smoker alone. So this is sort of like that big warning of like, yeah, mice data is all good, but this is like one of the first big human studies to show that the dual use of both vaping and cigarette smoking is having a noticeable impact on lung cancer incidence. So will it cause cancer? Yes. What about asthma? So this meta-analysis of 13 cross-sectional studies caught my eye because it found an association with asthma with current and ever e-cigarette use. And so in terms of like, why is this happening, we wanted to dig deeper and take a look. And also self-reported asthma. So one of my master's students, Sam Bell, exposed mice for 8 weeks and then induced asthma using the OVA model in the last 4 weeks. We exposed the mice to air on the far left and then air OVA, so our asthma controls in the turquoise, and then vehicle asthma in the cream, nicotine e-cigarette asthma in orange, and then the tobacco plus nicotine, the regular e-cigarette in the brown. And so what you might notice is that the vehicle looks like it drove up total lung cells, so increasing broadly inflammation, but the e-cigarette with nicotine and the tobacco flavor both suppress the total number of cells coming into the lungs. In terms of eosinophils, all three of them sort of blunted the influx of eosinophils into the lung. So we're trying to tease this apart, but this signal is similar to what we saw last year when we tried a couple different asthma models. So one thing I was talking about with other people is like, what's the driver here? So if there are a bunch of inflammatory flavors out there that people are using with asthma, that can drive asthma. Whereas if you have some flavors like tobacco and menthol that might be anti-inflammatory, you might not see that same finding in clinical asthma. So take it with a grain of salt. This is one e-cigarette type and 3 different chemical sets. The other thing that we worry about in human disease is systemic inflammation. And so when we ran our first human studies in 2016, 2017, we brought in really young people. They had never smoked. They were vapors. We took their plasma. We ran multiplex. And we found a broad increase in inflammation in the systemic circulation, but not in the airways. We just finished our recruitment of our second cohort and sent off our first sort of 10 panel of 10 cytokines. And the biggest signals coming up are interferon gamma and IL-10. And interestingly, the THC in blue versus the e-cigarette in red, looks like the THC vapors might have higher levels. And then purple are dual users of nicotine, e-cigarettes, and THC vapes. So this is just our first set, and we have a lot more to submit. So hopefully we'll have more data in the next couple of months. And this is just to mention, these are the different groups that we're recruiting. We just finished the first time point, and so we really want the longitudinal data, which I think will be a lot more informative to us. We've been taking nasal brushings, peripheral blood mononuclear cells, sputum, and PAX gene as a surrogate for neutrophils in the circulation. What might jump out at you right away is that the biggest sort of gene expression signal coming out is in the nasal brushings, which I find sort of fascinating because like e-cigarettes are sort of an oral process, but of course when you exhale, it comes out through the nose as well. So we're going to be digging into that to see what's happening in the nasal epithelium. Final piece of human data, we exposed some eosinophils ex vivo to different e-cigarette chemicals, again on this asthma front to try and figure out what might be driving asthma symptoms. And what we found is that the e-cigarette in blue has nicotine. It sort of paired with the e-vehicle, so the e-cigarette without nicotine in green, so these are paired together. And then down here, we found significant gene changes. Siglec-15 is pretty powerful on immune cells, had never been known to be expressed in eosinophils, so likely is changing its function. And then in our asthma cohort with our vapors, we're seeing elevations in eosinophils, but need to dive into that a little bit further. And final piece of mouse data for you. So this is actually the mouse data that scared me the most Maybe it should have been the cancer because of dual use, but these were mice that were only exposed to e-cigarettes with nicotine. And what happened was, well, they were exposed to jewel mango in orange and jewel mint in green versus the air controls in blue. And then we took their brains and we were able to cryodissect down to the nucleus accumbens and ran both qPCR and Western blots to detect TNF-alpha, IL-1 beta, and IL-6, so 3 super powerful pro-inflammatory cytokines. And what was worrisome is that at 1 month and 3 months, the TNF-alpha was increased in this part of the brain that's really critical for mood and memory. And then IL-1 beta had that same pattern in IL-6 as well. So this is just, we never want inflammation in the brain. So I really don't like it. And we are trying to do fMRI studies in humans to sort of see if this is happening in our youth who are sole vapors of nicotine. All right, circling back. So hopefully I've convinced you about some of these, if not all of these big 5 that I wanted you to walk away with. So they are changing the lungs. They will cause cancer. They're affecting organ systems across the body. I didn't show you our liver, heart, and kidney data, but we saw fibrosis. Dual use is worse than either one alone. So if you have a patient using both, get them to commit themselves to one or the other. And if your patient is inhaling something, odds are that they're inhaling more than just that one thing. And so people ask me what I ask my patients, and I say, like, are you inhaling anything, like anything at all besides air? And tell me about it. And then try and write down as many details as possible. In terms of policy, we talked a little bit about what's happened over time, but there's still a lot of opportunity at the local, state, and national and international levels. So some of the other countries have put limits on nicotine concentrations. So ours is at 60 milligrams per mil, but in the UK it's 20 milligrams per mil. UK never had the youth epidemic of vaping that we have. And people posit that that might be why, because you don't get that sort of shotgun beer high from 19 milligrams per mil versus 59 milligrams per mil. So this might make a big impact on youth initiation. Also want to ban flavors that target children, women, and people of color, because like menthol, sweet flavors are preferred by certain populations. And then ban sales near schools. So another study that somebody in the lab is actively working on is on different parts of town with different levels of socioeconomic status. Are there more vape shops near the schools in the lower SES? And so hopefully we can work towards banning those sales more. And finally, we've seen signals of the vehicle. So just the base chemicals of e-cigarettes are not safe. Nicotine's addictive, and using one inhalant leads to another. So a big thank you to all the collaborators who make this work possible. And then of course, everybody on the right who actually physically did all of this work, much appreciated. We have a really good time. I haven't uploaded the 2024 picture because we didn't get it in front of that sign. So I put in the 2023. So thank you very much. I'll take questions.
Thank you so much, Laura. That was a terrific talk. We're going to open it up for questions. And since I know there are going to be a lot of questions, I'm going to take the moderator's privilege and ask the first question so I get mine in there before the rush. So my question relates to what we were talking about this morning about funding for grants that we're all interested in. But the basic question is, what do you think is the most important thing we still need to learn about e-cigarettes? Or framed another way, what study would you most like to see funded to educate us all about this really important issue?
Yeah, I really want to know more about the immunomodulation. So, and specifically the cells of the lung, like the interstitial monocytes and the alveolar macrophages, like how exactly are they phenotypically and functionally changing? Because I think that will give us insight as to what diseases are coming. But the other thing is the endothelial studies coming through, because 90% of the chemicals that you inhale through a vape like immediately go into the bloodstream. So the endothelial exposure is like really high across the body. And in a lot of studies, that's been the highest signal that we've seen. And I think that can also be sort of insightful in terms of like, what exactly are these chemicals causing in the endothelial cells? So I think those would be my top two, but any grant with my name on it, I would want to see funded.
Thanks so much. All right, Carly.
Hi, Laura, that was great. Carly Rochester here. Really appreciate your talk. It was terrific. I wonder if, is there any data available about differential biologic responses to vaping, e-cig use amongst those with alpha-1 antitrypsin deficiency versus not? Because one could imagine there could be some different immunologic, inflammatory, either pro or the other way around responses.
That's a great question. I haven't heard of anything specific for alpha-1 antitrypsin, but I was talking to some people about some of the different emphysema data that has come out. And so there's a couple groups who have seen emphysematous changes in their mouse models of vaping. Others of us have not seen that, but I think it does come down to genetics combined with the exact e-cigarette combination, that it is going to cause sort of lung injury, destruction, inflammation in some genetic backgrounds and not in others based on the e-cig. So I'm not sure what else is to come, but I think that's a great question.
I think it might be interesting to study, especially
You know, amongst people with alpha-1 antitrypsin deficiency who are found to be ZZ homozygotes, many, if not most of them, are highly motivated to not be using any inhaled products if they learn about their condition. But there are so many heterozygotes of various forms out there who may not even have diagnosed heterozygosity. It just would really be, I think, an important thing to know as to whether vaping increases their susceptibility to COPD or asthma over and above people who don't have that.
I think a follow-up to that is that we don't know, like in our patients who are diagnosed with lung cancer, you know, is it safe for them to switch to e-cigarettes? And I would say absolutely not, but we don't have any data to support that. So sort of a switching study would also be nice.
Well, I must say, I was somewhat concerned. I'm really worried about these e-cigarettes now. This is much worse than I thought. When Steve Baldessari talks with us, he tells us that in his clinic, he tries to try every other technique short of the e-cigarettes. What are you doing at UCSD in terms of your addiction clinic and your smoking cessation clinic? How are you all handling this?
Yeah, I would agree with Stephen there, is that try everything else has been proven and gone through the best studies possible to see if you can get somebody to quit. But you know, I primarily work with veterans, and often they have tried everything and just nothing has worked. So I think I personally have not told anybody to try e-cigarettes, but they have gone out and tried them on their own, and sometimes they have worked. And again, particularly the new generation since 2017, basically, those can take the place. In terms of then quitting nicotine altogether, there is garnering data, accumulating data, that the same things that we do for our regular combustible smokers works for our nicotine vapors. So that's sort of the policy. If you have a vapor who's trying to quit, then you do all the same things that you would do for a smoker. Same thing on the adolescent front.
Thank you for that wonderful talk. My question is, I have a daughter who's a freshman in college, and I was surprised that she tells me everybody vapes. And so is there this whole thing related to weight in vaping, similar to like with combustible cigarettes?
I have not seen data to that effect, but I would.
Wow.
Oh, is that not working? Okay. Yeah, I have this mic on, but maybe it's not.
Is it on?
Okay.
No, it gets rid of she's in there.
Okay.
Okay.
But I think if you think about it in terms of like, you're doing something else with your mouth and it is activating a dopamine reward pathway. So do you need that Twinkie, or do you take the nicotine? So I would think that it is going to be that way. I do remember pre-pandemic, the college students, it's very helpful for me to have college students in my lab because they tell me about all the latest things and what people are using. And so it's like really, really helpful. But they would say that at parties, it's not alcohol being passed around, it's the vapes being passed around. Again, this is pre-pandemic, but yeah, they were literally just passing it from person to person. And, on one hand, I'm like, well, what's worse, like alcohol or nicotine? It's like they're both addictive, they're both dangerous. Like I almost pick nicotine for a college student, like definitely if they're driving or anything like that. So yes, I think college students is a high use situation, particularly in the social setting.
Thank you.
Hey, Laura, that was great. Thank you so much. So 2 questions. One is, I'm really impressed by the regional differences in inflammation that you're seeing. So, like in the brain or the GI tract, and I'm wondering if you could comment on whether this is this just a systemic effect of inflammation everywhere and you just found it everywhere? Or is this more like, for example, those microparticles are being taken up by macrophages within the brain or macrophages within the GI tract? Like what is your thought on that? And then I have a question about 6 differences.
Yeah, no, great question. And as I mentioned, I'll put this data in the talk tomorrow in case you're there. But yeah, we looked in the heart, kidney, liver, and the signals in each organ are different than in the other ones. So I do feel like, our organs are designed to handle challenges differently. So the heart, really tries to limit inflammation. And so we see it really shutting down inflammatory pathways once it's been chronically exposed. So I do feel like you have to think about, the immune response for that particular organ and what it overall is trying to achieve. And that sort of leads you to why it's having that response to the e-cigarettes. In terms of the brain itself, I'm not exactly sure, but we did check the cotinine and nicotine levels in that part of the brain, and they were there. So the chemicals themselves had, entered and gone to that part of the brain. But we would love to look at the microglia in that area to see, are they the ones driving it? I would guess that they are, and that they are sort of switched to a pro-inflammatory phenotype.
Thank you so much. And then the other question I had is about 6 differences. So you showed some really striking data, metabolomic, genomic, everywhere. And I was wondering if you have any insights into the effects of estrogen or 6 hormones, or what underlies the sex differences in their response to the e-cigarettes?
I have no idea. This is sort of my foray into this field. And so actually one of our postdocs, Alexia Perryman, she has started looking at the mouse models of sex differences. So it's like a 4 chromosome system, and you do all these surgeries and stuff. And so you end up with 4 different phenotypes to help you tease out the hormones versus other possible effects. So I think that's probably what it's going to take. But actually, she just went to a sex effects conference, and now they're tearing that mouse model apart for some flaws. So I was like, I don't know if we're ever going to get to the bottom of exactly why that's happening. But I would love to know, is it the macrophage, the innate state of, the female lung, the immune system in there that is having this different response? But great question. I would love to know that answer.
Another question I had. So I probably like you, I was very surprised when EVALI occurred and we discovered that a large portion of it was related to THC. I definitely didn't see that coming because I had always conceptualized e-cigarettes as being nicotine delivery systems, and we shortly learned thereafter that there are other drugs. My question is, do you see, or are you seeing any relative differences in risk between THC inhalation versus nicotine inhalation? Are there differences, or are a lot of the pathogenic components driven by the vehicle? What are you seeing there?
Yeah, great questions. So the THC vapes, typically use different vehicles such as coconut oil type stuff, like really thick stuff, which is actually why the vitamin E acetate was picked to cut it anyway, because it has the same thick consistency. And so the people who are selling the THC e-liquids could cut it 50-50 with the vitamin E acetate, and the buyers would think it had the same amount of THC in it. So it made sense of what they were doing. But yeah, those vehicles are very different. As you know, it's like really hard to study THC and cannabis in the US. So I've only like dabbled in the rodent work. But I would portend that they're going to have different effects. Our e-cig nicotine vape vehicles versus the THC vapes. One workaround is that, that's why we started recruiting the THC only vapors into our cohort. And so I'm really interested to see their sputum RNA-seq data, as well as their PBMCs, because on the clinical side, it seems like THC vapors have more clinical complaints about shortness of breath, cough. I don't know what you guys have seen here, but it just seems like it's had a bigger clinical signal than the nicotine vapes. So I just feel like it's more pro-inflammatory. But hopefully in the next 6 to 12 months, we'll actually have data.
Very interesting, thanks. I got a Finbar.
So this may be kind of a little bit of a kind of different thinking with respect to approaching the problem of risk in these patients, but accepting that there's going to be a certain degree of uptake and a certain difficulty with quitting these devices. Do you foresee any applicability of your research to mitigating the risk of the devices themselves? And so can things be done to make these systems safer? And is anyone working with companies? Have companies shown any interest in trying to make their devices safer?
Great questions. Thank you for asking that. So number one, we're not allowed to work with any tobacco company. Otherwise, I think you get shot is the outcome of that. I know that I'd be banned from ATS for life. And like on my disclosure slide, it wouldn't have allowed me to come speak anyway. So we aren't allowed to work with the companies, but in my early years, that really was my view of it, was that e-cigarettes are here forever. Like we're never getting rid of them. But if we could, find out what are the most toxic effects and advise the companies, and that I think would be a great outcome. I think that naturally, because in the early years of e-cigarettes, the majority of them owned by small businesses. And so they were making them in garages, they were making them, out of all kinds of parts, and there was like very little quality control. So that was the era of people being lit on fire, the explosions and whatnot. And so now e-cigarettes are owned 90% by big tobacco, so the big companies. And the one good thing there is that there is quality control and they're being made in factories. And so like we've really seen the explosions like go away. But I do think that the devices like and the e-liquids are cleaner. So they're like much more specific about what's going in there. The labels are still totally inaccurate. So if you buy an e-cigarette, like don't believe anything on the label, because our mass spec friends have checked like over and over again. And the ones that say no nicotine, they all have nicotine in them. But I do feel like that should be one of our responsibilities in the e-cigarette research world, is to try and give specific feedback on what's dangerous and like, if there is something that they could take out that, isn't going to change anything except decrease risk, then, we should definitely do that. But I think maybe it would be the policy people talking to the companies instead of the researchers. It really bothers my husband that Jewel has my home address because I have the e-cigarettes directly to my house, because it feels weird to have them shipped to the VA. So it's just my house. He also loves it that, I get these huge quantities of e-cigarettes and my kids like find the package and be like, oh, can I open it, mommy? And I'm like, no.
We're going to take a question from Zoom. Okay, Polly Sather would like to know, how do we get e-cigarette use to be part of the lung cancer screening eligibility criteria?
Oh, that's a great question. And we were talking about that at ATS, especially with the new sort of dual use data coming out. And I think a lot of people are struggling with that in general, because right now the screening criteria are so rigid, and yet we know people who had heavy secondhand smoke exposure at higher risk. So I haven't heard of anything happening at the policy level to change that. But technically, as a pulmonologist, you are allowed to screen people, may or may not get paid for. At the VA, they'll pay for it. So if you think somebody should be screened. I do think that should change, but I don't see that coming for years, just because it took us so long just to get the original indications for it. But I think it's important, and I think it should be done.
I think we have time for one last question that I'm going to ask, unless anyone else has anything. So one of the things that has been challenging for the field is that many e-cigarette users are former smokers. They have some cases have a long smoke exposure histories. They are switching over, and then it becomes difficult to prove that the e-cigarette exposure caused the illness. My question is, do we have ongoing either cohort studies or are you guys recruiting or able to recruit e-cigarette users who are never smokers, which I suspect would tend to be younger people? Older people probably would not be common because, as you pointed out, originally these products were picked up as smoking substitutes for many people. But what's happening with studies involving never smokers who use e-cigarettes? How are we doing in your lab and then in other places around the country, as far as you know?
Yeah, no, it is very difficult. And I think that's why our cohort at UCSD is relatively unique, because it's 18 to 35. And we were able to recruit people who are never smokers. In California, cannabis is legal as well. And it's like nigh impossible to find somebody who only uses nicotine vapes. Just all our dual and triple users. And so that's actually why we've had to change our strategy, because otherwise we just wouldn't be able to recruit. So it is challenging. I feel like you do have to go really young. And I'm hoping, and over time, as we're having the 1-year visits, now people have added in other inhalants. So my strategy of having like a super clean group to look at longitudinally isn't like panning out. But we like collaborate with the Channing, and they have like the COPD gene, and so they are tracking people who switch from cigarettes to vapes, and so we will get like that sort of inflammatory and immune data as well. And then there is another cohort in Denver that is like middle school, high school, but they have very high rates of cannabis use as well. So it is very difficult, and I think you just have to be very aggressive and hope that you can find pockets of people. And it's usually their friends. Like we find one that is a nicotine-only vapor, and then we find, we'll say like, do you have any friends? And we're like, yeah, because they tend to do the same things with their friend group. So that's one way to find a pocket of never smoker patients.
Thank you so much, Laura. That was terrific. We're all set.